Good evening again. Manoj here from Plotch.ai. Session basically is a little bit interesting session about AI. It is a little bit deep, but it's very, very interesting because vector search in AI is actually is becoming very, very a lot of people are researching on it. It's being adopted by a lot of folks. It is being used in AI like by almost every company in the world right now. So and you might not have heard of VectorDBs, but VectorDB is becoming mainstream. It is, people are saying that it will replace these and like MySQL in future, but actually I don't know well that will happen. But definitely VectorDBs are becoming very, very, very hot these days, and a lot of people are spending a lot of time in trying to understand how they work, how we can make them better, and those kind of stuff. So very interesting session around AI. If you want to learn about AI, Vector is something that you will come across anywhere you do research in AI, or or build any application AI kind of stuff. So I would next 30 minutes I would request feel free to ask me any question. Try to understand what this vector search and vector DB is, and make this a fruitful session for all of you. Before that, I would like to ask if any of you have any questions about this topic. Have you come across VectorDB? Are you using any kind of vector search in your organization? If you are, feel free to comment in the chat, or feel free to speak if you want to speak. Now, before I get into the vector, try to explain what vector search is and what how VectorDB is used, vector database is used. I wanted to share a little bit a very short demo to really tell you what I'm trying to what vector actually is trying to achieve, and it is basically based on the application that we have built. I'll probably share for join from my mobile quickly and show you a short demo, because I think it will help you understand what what VectorDB actually does in reality. Just give me like 30 seconds as I'm joining from my phone. But what I'm going to show is basically we have built a application called Coach, which actually uses vector search in the background, but it of course is uses a lot of other things to make it more relevant. Uh, but it is primarily the at the end of the pipe, search pipe in Coach, which is a relational search, a commerce search that we have done. Sorry, one second, I'm having. Sorry, I didn't plan for this demo, but I thought it will be useful for you all. I'm gonna turn the voice off and let me just share my screen. Oh, okay. I can't share. Why can't I share my screen? Oh, it's saying I have to stop first here. Okay. And let me just share my screen. Got it. Sorry for this, but I think it's gonna be useful for you all. So I'm just spending time a bit. So this basically is the application that we have, right? And I'm going to type few things, right? And show you, how vector search actually is enhancing the search experience here, right? Let's say I type Maggie, right? And you'll see that the Maggie has come as the first two searches. But what after that you see is basically some kind of noodles, the variety of noodles that you see. That's right. So although Maggie, the only two products in the Maggie in this, it is not stopping there. It is basically also fetching Maggie, other noodles and that is happening because of vector search. This is something you will not find if you are doing a keyword based search. This kind of behavior that Maggie is actually, even though Maggie is not there, it's showing noodles or some other brands of noodles kind of stuff, right? Another example I want to show is, for example, let's say I don't have Nike shoes here, right? But I'm typing Nike. It's such simple typing Nike, right? But it's showing me shoes. It's not showing me shirt, or it's not showing me, food, or some other fun, right? Because Nike is very well associated, very much associated with shoes as such, right? So although Nike shoes are not there, it's showing me campus shoes. Uh, it is showing me shoes, right? And that basically is also something which is interesting application coming out of vector search, and not it's not doing a keyword search, right? A keyword searches are primarily when you search for a keyword like Nike in a product name, or in the brand, or in the product description, right? It's primarily looking at the relation, and if it's not able to find, say, Nike shoes, showing me shoes at least kind of stuff, right? The third thing basically is to show you some kind of relation is, let's say, cat print, sorry, cat print clothing, right? I'm just trying this for, right? So let's say I'm looking for cat print clothing, right? So it is showing me cat printed clothing, right? Some kind of t-shirts and those kind of stuff, right? It is showing me this, showing me even the print of like a, leopard and those kind of stuff, right? So it, even though it's a cat print, it also showing me leopard prints, right? So it's basically it has understood that, cat and leopard are the same cat family, right? And therefore it is showing me, right? If I say, lion print, let's say lion is another cat family, right? A lion print clothing, right? So it's showing me leopard clothing. It designed have lions, so it's some lion here. But interesting thing is the same product. When I say cat print clothing and a lion print clothing, even if I do leopard print clothing, it will show me the same product, because it is identifying that cat, leopard, and someone who is probably interested in cat may also be interested in leopard. It's that's something, is a relation that's trying to build, right? So this is something I wanted to show, because this is this is the classic application or usefulness of vector search, right? Vector search works very different from a keywords based search, and that's basically something very interesting. Now, vector search is of course used in searches. Vector uh, it's also used for recommendations, right? So it's not just for search. It's, you may also, it may also show you similar products. Like I was showing, actually, you're showing more like similar products. So if I say show me products similar to this product, it also show me products similar to that, right? Clustering and classification. It can cluster and classify that, these are the similar reviews, these are the similar reviews, and these are similar reviews kind of stuff. For example, it can classify these are bad reviews and these are good reviews kind of stuff. So clustering classification also it can do, anomaly detection, primarily into fraud, right? If something is happening out of the way, because of the vector, and you will learn more about vector, as I said, and you will relate what I'm saying here as I go further. But primarily fraud detection, anomaly detection, basically something which is outlier, something which is not in the related set. You can basically treat that as something which is happening as a fraud kind of stuff, right? So that also is a big application of vector. Now I just showed, I was showing, the search Maggie, right? Maggie, from a keyword match, you'll only get Maggie products, right? Either it's the Maggie in the name, Maggie in the brand, Maggie, somewhere, in the description. But when you're doing vector match, right? Of course, Maggie is being matched to Maggie from a vector perspective, but also being matched to noodle or other brands of noodle, or even like remotely, some kind of, you can say Chinese food and those kinds of stuff, right? So there is that relation which is in vector. Vector search works on relation. It doesn't work on exact keyword being there. That is one of the fundamental difference between keyword based searches, which we usually do, uh, which you usually implement search on, and a vector match, which basically is completely working on the relation. Now, the relation basically, now let's get deeper into this vector search. How, what is this vector? And you're talking about vector. What actually is a vector? Now, vector basically is what happens is machines don't understand, they don't understand strings as such. They don't understand text. They understand numbers. That basically machines are very, very good at, right? So if you can convert what I'm querying, what my search phase is, or my text string is, or even my image or my video into some kind of numerical representation, some kind of representation where I can say that Maggie actually is 1, 2, 3, 4, while noodle is 1, 2, 3, 7, for example, like that, some kind of vector representation. Now, if you have done basic, maths, or you might have heard of these vectors being there, like in 2-dimensional, 3-dimensional vectors. But in this, when we are looking at vector search, the dimensions can be more than 3, right? It can be 768 dimension, it can be 1500, 34 dimension, that kind of numbers, right? So dimensions, the more the dimensions are, the richer the vector is, and the more richer the vector is, the better, performance you'll get, kind of stuff. So therefore, in vector search, primarily what you're looking at is converting a sort of a text string into a vector, which is a numerical representation, kind of stuff. Like, for example, Maggie and noodle, they are two different words, right? And they, in a vector space, they are represented as one vector and noodle as another vector, right? And shoes is the third vector, right? Which you can create, right? Now, how the vector works is that it will actually create distance. It will actually find the distance between these two vectors, the Maggie vector and the noodle vector. And then also it will find the distance between Maggie vector and shoes vector, right? And because the distance between Maggie vector and noodle vector is closer, it will actually show noodles, when you're searching for Maggie, and it may not show shoes, kind of stuff, right? Because distance of vector between Maggie and shoes is actually different. Now, the different methodologies using which you create this distance, now the cosine similarity, there's dot product similarity, the dot product method, then there's Euclidean method. All these are different ways to say how far is one vector from another vector, right? Now, Euclidean primarily is the distance, is the direct distance, right? It is the direct distance between Maggie and shoes, which is the length of the D2 and the length of D1, right? So that basically is a Euclidean kind of distance. So if D2 is greater than D1, that means D2 is far, which means it's not related to Maggie, kind of stuff. Now, cosine similarity is only looking at the angle, how far the angle is, like how diverge the vector is, kind of. It is not looking at the length of the vector, or the distance between the vector. It's primarily looking at the how far the divergence is in the angle, kind of stuff, right? So that is cosine similarity. Now, I'm talking about cosine similarity, I'm talking about Euclidean, I'm talking about dot product, because these are the things you will have to, if you are looking at implementing vector search, you will have to take a call, which distance, algorithm will I be using, right? And as I said, closer the distance, the more related the strings are. Vectors are floating point representation of a phrase in a n dimension. Any questions before I get into a little bit more detail on how we do vector search and those kinds of stuff? Because fundamentally, if you understand that, how do you do how that vectors actually creation numerical representation of whatever I'm saying, whatever the phrase I'm saying or the text I'm saying, and then creating distances. It's a very, very different concept when we are looking at keyword-based search, where we're actually saying, okay, this sentence have Maggie keyword, does it have shoes keyword, does it have Nike keyword, those kind of stuff, right? and all these concepts, actually the vectors are coming out of AI, the LLM models, right? So the whole vector creation algorithms are actually output of LLMs, the large language models, and I'll get into the detail more. Any questions? I know it's a little bit heavy for some of you folks, but any questions on till what I've talked about?
No, not till now.
Okay, so everyone understands that vector searches are important. They're looking at similarity rather than exact keyword or those kind of stuff. And a good part of what similarity is that sari and sari, and I can show that in, or maybe I can share the link with you. SARI, SAREE, SADI, SARIS, SARREES, plural, singular, different variations of sari. For vector, it is pretty much close. If you look at the vector of all these uh, string in this vector domain, they actually be very, very close, which means that you don't have to manage, the spelling mistakes. You don't have to manage plural, singular when you're doing vector search. While that becomes a bigger problem when you're doing keyword match, because you have to handle your plurals and singulars and your misspellings and those kind of stuff, auto correction, everything. Here, basically, because it's similar in nature, all these sari and sari, because all these vector dimensions actually coming from the knowledge of a large language model. So in large language model like OpenAI and Chat GPT, GPT basically, they know that Sadi and Sadi are pretty much similar. So in their internal representation also they're creating vectors, right? And therefore all this is basically that knowledge is coming in when you're creating a vector kind of stuff, right? So that's another interesting thing, the similarity of the keyword in how we speak and how we understand is also embedded in the vector kind of stuff, right? It's not just a relation, it's a similarity also. Uh, this basically is a very high level diagram of how if you have to implement vector search in your organization, what you will do, right? You will have to choose a vector DB. Vector database is where your vectors are stored, right? And that can be there's a list I have basically. If I this is basically some of the prominent vector DBs, right? You are aware of Elasticsearch. If you're already doing keyword based searches, you might be using Elasticsearch. So Elasticsearch supports vector search also. Redis now Redis is a cache. Now, when you're saying cache, when I'm saying I need this data, I have a cache key, right? This 1, 2, 3, 4. But sometimes, I may want a very similar kind of if a key value kind of stuff, right? So Redis also supports vector searches now. So if you are using Redis, I think the later versions of Redis, not the earlier version of Redis, even the Elasticsearch, the later version of Elasticsearch have support of vector. Now Vertex by Google, Google has a product called Vertex, which actually we also use for our application. They basically also provide this vector DB and vector searches kind of stuff. Pinecone is another company which is doing very well right now. Again, only does vector searches. Now, of course, Elasticsearch and Redis do other things, but Pinecone, Chroma, DB, VV8, Crudant, Milvus, all these are primarily doing vector searches. Because there's so many vector DBs are coming, you can realize that how much interest is there in vector DBs, right? If you are attending this webinar, this basically is also an indication if we are doing a webinar, right? Because vector DBs are very, very, very important stuff, right? Now, this is basically, as I said, vector DB is the heart, where, it's basically where you store all the vectors kind of stuff. Now, to store the vector, when you have to, it's called the indexing, of the documents. Either documents can be products, right? It can be images, it can be videos, whatever, they're multi, dimension vectors also. So multi-domain vectors also you can create. Like I can create image vectors, or not only string vectors, or image vectors also I can create. So right. So first, what you do is whatever products you have, right? Product A, product B, product C. If I'm taking an e-commerce example, but let's say product A, product B, product C, product C, you basically create use an embedding model. These embedding models are available with any of the large language models. Like OpenAI has multiple embedding models. Google Gemini has multiple embedding models. Pinecone themselves have multi embedding models. You can go to Hugging Face and get a lot of other multi embedding models. So you can use embedding models. Now, how to choose embedding models, which are the best embedding models, is also an experiment. We tried like at least 5, 6 embedding models to come to one embedding model that, this embedding model is what works, kind of stuff, right? And then once you choose an embedding model, you push, let's say, product name. Let's say product name is what you want to vectorize, right? So you push the product through embedding model and create a vector, and that vector is what you push into VectorDB, not the product name, right? Is not the product name which is going into the VectorDB. It is the vector of the product name which is going into VectorDB, and that is a fundamental difference. If you follow it like that, that's a fundamental difference between Elasticsearch, where you actually documenting your product name, you're indexing a product name, but here actually indexing a vector. Now, Elasticsearch also, if you use Elasticsearch for vector, right, search, you will not be pushing product name. You will be pushing the vector in the document, and in the Elasticsearch kind of stuff. Now, there's a whole indexing activity that you will do. Like if you have 1,000,000 products, you will index them. And that basically continuously, if new products are coming, you will keep on indexing, right? So there's this whole path of indexing, which really where you take the product name, you create a vector through embedding model, and then put it in a vector DB. Now, as a customer, if someone is searching, let's say I have a query, right? That basically goes to the same path. I have a search. Let's say I search for Nike. Nike will go through embedding model, create a vector, and then in real time it will create distances, right, between all the documents which are present, and it will quickly tell you that these are the nearest neighbors. This is what we call, there's a K near KNN, and these kind of terminology people use, just K nearest neighbors, right? Let's say 10 nearest neighbors or 20 nearest neighbors to that vector, that query that I have, right? And that 10 or 20 or 50, whatever nearest neighbors you want, those search results will come, and then you display them, right? That's how basically the whole vector search works. A, you have to index, and B, then you have to real time, you have to create a vector, and create a distance. Now, usually all these pine cones and vertex and Elasticsearch, they have their own internal algorithms to create distance, right? So you just tell them that I want to use cosine similarity, or I want to use dot product, I want to use let's say Euclidean, or some other distance, algorithm, if they have, right? That's the only thing you say, and you also say what kind of embedding model that I'm using, and then basically, that's that. So now, embedding model while you're indexing and embedding model while you're querying has to be same, right? That's a fundamental thing that you cannot say, okay, I will use embedding model A while I'm indexing, and while I'm searching, I will use embedding model B, right? So that even from the same LLM, right, it is advisable that you use same embedding model while you're indexing and while you're querying, right? That basically is also something I wanted to highlight. Now, speed of index and speed of query is also important, right? So if your embedding model is taking time, right, then it is a problem that you need to solve for, right? We have seen some embedding models take like 1 second, to create a vector. Some embedding models are creating 5 seconds to create a vector. Right? Some embedding models are creating 500 milliseconds to create a vector. Right? That vector creation time is very, very important, right? Your most of your DB, distance calculations are very, very quick, but vector calculation time is very, very critical. And that's what we also found in a hard way, that, this embedding model is better versus this embedding model versus this embedding model. Kind of. So that also is something that you need to take care of while you are working. Now, some of the embedding, models have a cost, right? So speed is one part that I highlighted. The cost is another part, right? Now, if you're using OpenAI APIs, or if you're using, Vertex, Gemini APIs, or those times, there might be cost associated with creating embedding vector using those APIs, and that cost also is something that you need to account for while you are working on this vector search. Any questions on this? I'm hoping that every one of you can follow what I'm saying. Even if you're not, even if you go back with very, very clear understanding that vector DB and vector searches, and how, very high level how vector works, search works, that also is fine, because this is this is a deep topic as such. It is not a very, simple topic to understand, but it's an important topic in your organization. I don't know, if you are a developer, if you are in the senior management of the company, or if you are, a CTO of the company, but understanding that, this is a very, very important part, an important piece which is coming in search and recommendation and clustering and fraud detection, so that you can go back to your team and say that, have you looked at vector DB? Have you looked at vector search? It is a very important question that you can ask after going to this webinar.
Hi Manoj.
Yeah,
I just have a question that can you show the embedded models as an example for an embedded model?
yeah. Let me show it to you. I might have to change my screen. One sec. I'll show you how OpenAI does it, right? Very
Okay,
quickly, right?
okay.
One sec. So let's. I'm just typing. Everyone can see my Chrome browser, right?
Yeah,
Right. If I type OpenAI embeddings, right? So this is what I get: OpenAI embeddings, right? And right, it basically at the top itself it says the test embedding 3 small, test embedding 3 large are our newest and most performant embedding models now available with lower costs.
we
So
are
they are
just
saying,
able to see view your search bar, not the full screen of your
oh,
browser.
okay, one sec, one sec, one sec. Why is it happening? How about now?
Yeah, it's visible now.
Yeah,
Yep.
yeah. So this is OpenAI, right? And basically embeddings page. And here it's saying that at the top itself that these are the two models which are our latest model, which is test embedding 3 small and test embedding 3 large, or newest and most performant embedding, right? Now, small and large primarily means how many vector dimensions, right? So usually small has 768 dimensions, and large has double of that, which is basically 15, whatever, 34, something like kind of stuff, right? That basically is large and smaller, and this is text embedding. This is not image embedding, right? So they are multimodal embedding models also, but this is primarily we're talking about text embedding, right? Kind of stuff. And basically talks about search clustering. These are the, I've already talked about that. These are the things which is used. Now, this is basically is example of how to get embeddings, which is basically how to get vectors. Embeddings is basically used you know, in some ways, embeddings and vector are pretty much used same ways in the terminology. You can say that. So when I'm saying embeddings, it's primarily with embedding vector kind of stuff, right? So how to get embeddings is basically you'd say your what is your model, which is text embedding 3 small, and your input text, which can be your Nike or Maggie or whatever type you use, and use your OpenAI key. This is, and then basically you get this vector, right? Now this is a vector, right? Embedding object is embedding vector, and this basically vector is just numbers,
Mm-hmm.
right? You can see this is embedding, and this embedding is what goes in the vector DB, right? This is what you will store in the vector DB and stuff, right? And this embedding is also what you will use to query. So if you get any query here, you will basically use this model to get embedding vector, and then give it to a vector DB to give you the results kind of stuff, right?
Okay.
And this embedding model, while you're querying and while you are indexing, has to be same kind of stuff, right? Right. So this is how you get the embedding vectors,
Mm-hmm.
and these are the embedding models, right? So basically, text embedding 3 small is one model, text embedding 3 large another model, and text embedding this AD802 is another model, right? These are the 3 different models which OpenAI has created, and these are basically uh, inputs. So this cannot be more than 8191 tokens. Tokens is primarily, you can say, number of words. So it cannot be more than that while querying. And how many pages per dollar, that this is a dollar cost. So now each page might be some 100 tokens or something, right? Assuming 800 tokens per page. A token is usually word. A token in AI, it's not actually exactly word, but to simplify, basically it means words.
Okay.
And yeah, and then basically you use this. You can use these embeddings to there's some examples given, like how do you can use this for reviews, clustering of reviews, like bad reviews and good reviews or very good reviews, right? Some people even say happy review, joy review, sad review also. So all that clustering can be done of kind of stuff as an example. Yeah, and I can do the same thing with the Google, for example. If you want, I can go to Google and embedding model, Gemini embedding model, we usually just say, or the Google embedding models. So here basically again they're talking about
Mm-hmm.
embedding models here, which is basically text embedding gecko model, which has 768 dimensional vectors.
Okay.
And these are different models which are available. This is multilingual models. If you want to use multilingual, like if you want to speak, have the same query in Hindi, English, Marathi, Kannada, whatever, then you can use a multilingual model also. Any other questions?
So basically, we have to just get each time our embedded models to search, or while creating products to save the embedded models for the search,
Yeah,
right?
you take the search. Basically, first thing you will do is take all your product. Let's say I'm taking an e-commerce example. You will
Mm-hmm.
take your product name, right? Your product name is, let's say, Maggi masala noodle, something like that, right? And then you will use an embedding model to create a vector, right? And that vector is what you will store in the DB,
Okay.
vector DB.
Mm-hmm.
That's the first thing that you will do. Now, if now someone searches Maggie, then you will use the same embedding model to create a vector, and then you will query the database with that vector.
Okay. The
So
list
what?
of which
Yeah, yeah,
you
yeah.
get. Okay.
Right. So that's how you get the vectors back. Now, I did not talk about metadata. When you're storing vectors, you can also store metadata along with it, which can be the product name, for example, a product ID. It can be like other attributes like color and those kind of stuff. So you can also filter
Mhm.
So I may say that I am looking for, let's say Maggie. So but I want to only search in category which is food and or maybe grocery kind of stuff, right? I don't want to search any other
Mhm.
category. So I can give my category as a filter while I'm doing vector search kind of stuff, right? So that also is something that you can do in Pinecone, in Vertex also, in Elasticsearch also. We have tried all three. So yeah.
Is this vector DB some different from our normal DB which we create?
Yes, yes, yes.
Can
Now,
you?
so let's say you go to Pinecone, right? Pinecone is basically a serverless DB. You don't need to install the DB. You basically use APIs to store your data and also do the query
Mhm.
and stuff, right? So it is one of the largest vector DBs which are available. It's different from MySQL. This is not MySQL,
Okay, okay, okay. Yeah, got it.
right? This is not MySQL. All these people are using this, you know,
Mm-hmm.
Pinecone. Then we have other DBs like Qdrant. Some of them are open source. Like Pinecone is not an open source vector DB. Some of the others are. So it is again the code Qdrant is an open source database, right? So you don't have to pay for it. You can download and you can use it, right? So it's again a high performance vector search at scale kind of stuff, right? Um, yeah, I think PostgreSQL has an
Vector search.
inbuilt vector search.
Okay.
MySQL doesn't.
Okay.
Any other question from anyone?
It's clear now.
Okay. Great. With that, we had only actually allocated 30 minutes, but we exceeded and made it 40. I hope you got a good sense of what vector search is, what vector DBs are, why vector search is interesting because of similarity. It is not doing a keyword search, right? And it has a lot of these all these vectors have a lot of AI knowledge which is coming from the large language models, which basically consume a lot of data, and then these vectors are created which has a lot of data because of all that, right? So how vectors and why vectors have that data is another topic to discuss, right? Kind of stuff. But fundamentally, this is a concept. I hope you like the webinar. I hope it's useful for you, and you can build interesting applications on AI using this. Yeah. With that, I want to thank you and have a great weekend. Bye bye.
Bye. Thank you.